HyperC concepts. As you already know, HyperC works on tables and execute commands. And this allows you to do all sorts of table automations and very complex optimizations with a very familiar spreadsheet interface and spreadsheet formulas. So let's see how it works. The two main concepts of HyperC is selecting a command and selecting a row. And selecting a command and selecting a row, the HyperC does to satisfy your constraints in the most optimal fashion. So for constraints, we have a separate constraint field, I will show you in this video, that accepts typical Excel formulas. So again, HyperC selects to execute a command and selects a row from your table that most optimally fits to reach to the goal in the most optimal fashion with least commands executed. So let's see how it works on this example. So this is a very simple example. We see only two values in this table, number 1 and number 2. These are 1 and 5. And in dashboard, we have target number 14 and the current number is 0. So we want to increase this number multiple times to create this automation, to increase this number multiple times to finally get to 14. So let's create a command. And the first command I'll create, I will call check. And this will be a very simple command that will do only won't do anything at all. It will only check the constraint. And I'll click in this constraint field. So the constraint field is designated by this filter sign. So I'll click on A2, which is what you expect from Excel's experience, and I'll click on B2, and I'll have this formula A2 equal B2. So if I hit enter, HyperC will immediately start thinking and will try to satisfy the goal. It will not be able to satisfy it because there is not enough commands or information that HyperC has to satisfy that. So in order to do this, I'll add another command. I'll call this command increase by 1. And in this command, what I'll do is I'll do a very simple thing. I'll put in A2 here that A2 will equal A2 plus 1. And we will immediately notice that now check has this green check here, and ink by 1 also has this green, and in ink by 1 we can see in the plan panel in the bottom right that it was successfully executed. In the dashboard we can check that it is now 1, so this command was successfully run, and we can see that check was also run, and in the dashboard we can see that the current number is currently 14, and the plan in the bottom right, you can see it run it 14 times finally to have check running. So let's add another command, and this command I'll call select number. In this command, what we will do is we will select a row from the numbers spreadsheet, from the numbers sheet, and to do this I'll click this button that literally says auto select a row, and it will immediately pop out. It will show this one single row. So it doesn't show anything, but you can imagine that this is how it shows that it selected one row. So it does one row selection from the numbers table. In order to increase the value in our table above in dashboard, what I'll do is I'll add another step, and in this step I'll be working with the dashboard table over here, and I'll do pretty much the same thing as I did before. So I'll click over here. So let me make the output smaller for the convenience, and I'll start doing the same thing. I'll say that I want here A2 equal A2 plus, and now I'll click on B in our selected row over here, and we'll have the reference in this field. And why did I do this is because I want HyperC to automatically decide what will be the most optimal way to get there, well, to increase the value. And yeah, we can see over here that it did execute this. That's how you can check that whatever you entered is correct, is that this action is actually running. And if we click on check, we suddenly see a difference here is that it did it in somewhat different way, right? So it didn't run increase multiple times anymore, but it did select number 2 times and then increase 1, 2, 3, 4, right? So what it did is it selected the number 2 times. Obviously, it selected number 5 because that's the most optimal way to get there. And in the dashboard, instead of 0, in the bottom, we can now see that it is now 14, right? So the same result, but it selected a different command, well, a set of commands, and it also selected the right row to get there. So what we can do is we can, for example, remove this action, increase by 1. And we will see that the way it calculated is now different. Let's see. So you can see now it did select number many times, right? Because it selected the number 1 and number 5. Well, obviously it selected number 5 2 times, and it selected number 1 four times that are left. And let's see if we can see, well, because here in the bottom right panel we cannot see what it did, what actually decisions did it make. So let's create another table. I'll call the table log. And in this log table, we will have only one column. I'll call this column so number selected. And in the select number action, what we will work on is we will add another step Y, and we will work on log. And here I'll use this button that's called add row. So I'll make the output smaller. So I'll click on add row, and I'll see another line pop out. And here what I'll do is I'll just say that this should equal, and I'll scroll up and click on A, because A now contains the number. And let's see what difference does it make for our check action. And let's see log. And we can see over here that that's exactly what it did, right? What I anticipated it to do is the optimal way to choose number 2 2 times because it was 5, and to choose number 1 4 times. So again, this is the input. You can see what the input was like before and the output over here. So these two concepts, selecting a row in the most optimal fashion and selecting the most optimal command, allows you to do and to solve pretty much any optimization problem. So the statement that I made here is that you can encode any optimization problem using these two concepts in a constraint field and solve it with HyperC without using of any of the fancy and sophisticated solvers, without using the solver function of Excel itself, without any programming. You can achieve the same result as a typical high-profile engineer would be able to do with conventional programming methods. So let's try to solve something more advanced than this.